Warahmatullahi wabarakatuh. A very good morning, ladies and gentlemen. Welcome to the Team Excellence Seminar 2014. I am Ayo.
And I am CKT.
Very glad to be here to present our second project today at this hall. Our team project title is to reduce insufficient solder defects at SMT process and have been approved by top management. Our company have been recognized with a various types numbers of certificates and have been approved by international quality standard. We produce a various types of fax machine, telephone decks, panel boards, and latest product is smartphone. Our product was distributed throughout a worldwide customer. Our circle consists of 10 members. We have Mr. Aziz as our facilitator, Mr. Ayub, me myself as a circle leader, and others hardworking members with job from data analysis to booklet preparation. We started our journey from 2006, won third places National Konvensyen 2008, and latest achievement won third place on the World Panasonic Konvensyen in Japan on September 2013. An activity plan was drafted to assign specific role for each member. During action taken, there is a delay due to the in-house making tight schedule and so on.
Let's take a look at ASMT process flow, starting from PCB loading, then to solder printing process, followed by bonding process, then to mounting process, curing process, and finally to circuit inspection. 6 teams were suggested from members. Among the 6 teams, insufficient solder gets the highest point, based on monthly IPQ data and potential to reduce. This team was selected is due to top highest IPQ defect and top highest market claim defect item. The third reason is the AIPCB top management policy main activity, and fourth factor is top loss cost and loss time with total amount of 384,000 ringgit per year.
By review on the last 3 months IPQ data start from February to April 2012 and found out insufficient solder is a top highest defect with an average of 26% and top highest ppm with an average of 3.8 ppm. From the 3-month insufficient solder data, we combine and segregate to top 10 causes. As a result, and found out there are 3 main major causes contribute on this insufficient solder. Target setting was set based on Urusi Baru chart target plan and AIPCB top management target setting. And from these 2 factors, we plan to reduce by 50%. Insufficient solder occurred when the amount of solder paste deposited on the PCB by the solder printer is much less than the stencil opening design. By using an Ishikawa diagram, we started our brainstorming to break down the root cause and follow up by the sub-causes and identify that 9 potential causes which could contribute on this insufficient solder and need for further study.
Through cause screening table, we break down again the potential causes and identify 3 main possible causes. From machine is solder landing less, from method is PCB warpage, and from material is arc casing lifted.
What Katie? May I know what is PCB warpage?
Well, PCB warpage is board with twist curve surface.
So, how does the PCB warpage could affect the insufficient solder?
This is due to unbalanced board surface, which will cause some lead pin not contact with solder landing.
How does this happen?
It's happened during curing process. The PCB pin head up and twist due to PCB material made of paper.
Why the pin not fully covered?
Under analysis and carrying out brainstorming. Through YY analysis, found out pin not enough fillet due to PCB warpage. The warpage golden shape to flat surface is due to rubber block too soft to push the pin. As the result, the rubber block not suitable and need further study.
On our first idea, by introducing a support magnet pin, and found out the magnetic field could easily attract the waste metal chip. As for solution, we create a pin compartment and place it outside the machine. Second, the strong magnetic field preventing the pin from lifted. As a result, this idea is more practical and effective. As for reflow 1 process, we introduce a support plate with pin lock. On first finding, the pin can't fully lock the plate, cause the plate lifted. The plate also too short and not suitable use for long type PCB. As a conclusion, we assume that this idea is not practical. Next, we came out with a unique solution by introducing a magnet support plate and found out the warpage board had been reduced to the flattened shape. The plate lying more longer. Thirdly, the 6 strong magnetic pole fixed for the strong hole on plate. On field finding, the magnet block was designed placing side by side in order to run a small width size PCB. Plate installation is more easy and quick during model changeover. The implementation cost saved by 90% by using a recycled material. And finally, the results show that this idea is much more effective. And from the 3 ideas taken, we summarize it by using a selection metric and found out the magnet pin and the magnet plate get the highest point and selected as our countermeasure. The first countermeasure showed that the ppm value reduced from 3.8 to 2.7 ppm. We have reduced 29% reduction, but we still didn't achieve our target.
Next is our second analysis on RF casing lifted. It is a metal casing that mounted onto PCB, but due to some reason, the casing is unbalanced or unaccurate. This caused the casing lifted from the solder landing. Through YY analysis, the casing lifted due to pickup knot center. The pick knot center is due to casing tray out of machine tray alignment. The supplier tray is too soft and easily floating. As the conclusion, the plastic tray the main cause of casing lifted and need further study. The first idea by introduce a metal bar and fix a tray edge. On first finding, pickup more accurate and found out casing shifted before pickup due to big tolerance gap. As the result, this first idea not practical. On second unique selection by introduce a direct tray. First find that the pocket gap have been reduced by 0.05 mm times 0.2 mm and eliminate casing shifted inside pocket. Secondly, the casing more stable and firmly sit onto pocket. Thirdly, we are able to eliminate from tray lifted during clamping due to hardened tray made of Duracon.
During the 2-week observation, found out the Duracon tray warpage is due to the pocket cutting depth. As the solution, we modified an attached aluminum plate. On field finding, we could reduce the mounting time and eliminate nozzle turn 90 degrees, which could cause us casing shifted. And finally, this idea is more effective and acceptable. Our idea number 3, by introducing a recycled IC tray, found out pocket tray gap much smaller compared to the origin tray. Secondly, the IC tray material is more hardened, which can eliminate tray warpage. Third finding is a casing floating due to the IC pocket not suited with the casing and floating by 1.14 mm. So the solution for this problem, by widening the line and width by 0.7 mm on each side. On fourth finding, the casing floating unbalanced is due to the casing hook. The solution is by drill hole at the hook tray placement. The implementation cost saved by 4,000 ringgit if compared to the Duracon tray. The replacement tray stock also available on daily production. The results show that the defect reduced by 53% and the idea is acceptable. From all countermeasures taken and found out the solution number 2 and number 3 get highest point and selected as our countermeasure. After second countermeasure, ppm have reduced from 3.8 to 2.1 ppm. 45% reduction have been done, but we still didn't achieve our target. Next is our third analysis on solder landing lens. Solder landing lens is the amount of solder paste deposited on the PCB are less than the stencil opening design. It happened due to the hardened solder stuck at the stencil opening edge.
By using YY analysis, found out IC 600 solder lens due to solder landing not fully covered onto copper pattern. First factor is PCB copper pattern with not consistent. Second factor is pin pallet floating and shifted during curing process. As the result, need to study on stencil opening. On our first idea, we widened the pin opening and logging the length by 0.15 mm and reduced solder cover area by 30%. Found out IC more stable during curing process due to ground solder thin. Secondly, could reduce solder consumption by 30%. As the result, this idea more effective and acceptable. Next, analysis on solder leftover. During printing process, the block will push the stencil upwards, which causes the stencil surface which become opaque. This is due to not support pin to push the stopper upwards because the support block designed to locate pin at PCB area only. As the conclusion, the support block need to study for improvement. Our first idea, we introduced a triangle metal block. First finding, the metal block is too heavy, that is 2.2 kg, and may cause the exploitable motor damage. Second, the metal block is easily rusted and sometimes could mix the solder. The implementation cost is too high the standardized at all 10 SMT lines. As the result, this idea not is practical as well.
On second idea, by introduce a Durokan magnet block. The Durokan was placed exactly at the bottom squeegee stopper to prevent the stencil from warpage, and the blade lifespan is more longer. The block also protect the pin from damage if dropped or knocked and reduce the model change time. As the conclusion, this idea is effective and acceptable. Next analysis is on solder harden. The machine stopped too long causes the solder harden. This is due to not following the standard stencil cleaning procedure when the machine idle is for more than 15 minutes. There is also no command and warning information from the machine to highlight on the stencil cleaning. As a result, they need to study on the auto stop machine. To solve this problem, we introduced an auto stop inspection software. A first finding, we could eliminate a one manpower as a stencil cleaner. Secondly, we could reduce also one manpower who is cyclone inspector and save 35,000 ringgit. As a result, this idea is more efficient and acceptable. From the four ideas taken, found out solution number 1, number 3, and number 4 get highest point and selected as our countermeasure. On our third countermeasure, show that the ppm value reduced from 3.8 to 1 ppm, which means we have reduced 74% compared with our target 50%. Our countermeasure taken, finally, we standardize it and spin off to all line evolve and follow up by every countermeasure by person in charge.
During countermeasure taken, we also create some question point in order to teach production members the defects. Before, the countermeasure insufficient solder achieved 3.8 ppm and reduced to 0.8 ppm from June to July 2013 during monitoring stage. Overall, we successfully reduced by 82% against our target 50%. And at the same time, the top 6 defects also reduced by 54%. From the 4 countermeasures taken, also we found out the defect from other 3 items also reduced by 51% average due to the impact from these 4 actions. As for overall defect item, the ppm reduced from 70.5 ppm on month of February 2012 to 7.7 ppm on month of July 2013 during monitoring stage. Overall, reduction is 56%.
Throughout 1 year, AISMT do have carried out recycling activity to reduce a perishable to cost. After project implementation, we are able to reduce from 31,900 ringgit to 11,000 ringgit per month. After deduct from the implementation cost, total cost saving is 8,391 ringgit per year. From project implementation taken, there is a negative impact to stakeholder from the 8 main areas such as supplier, subcon, company, customer, and etc. As for positive impact, the stakeholder also affect at the 8 main areas and could upgrade our quality, image company, good delivery, and increase company profit. During project run, we do have some difficulty facing, but with the support from the other department, we are able to overcome the problem arise.
Sharing information and transfer technologies and knowledge on project taken to subordinates is our main priority in order to make sure every production member not left behind. From the cost saving we achieved, finally, our circle had been recognized by top management and finance department on our strong efforts for the improvement of our company. Our company also they have a corporation social responsibility activities on cooperation with Johor Authority. After project completed, based on self-evaluation summary report, there is significant increase among members involved from 45% to 76%, and that is improvement by 31%.
That's all from us. Success. Thank you for your kind attention. I thank you.